Hey guys, alrighty, second lecture in chapter 11 here, and this is, I should say chapter 12. Let me get that right. We're in chapter 12 now. Did I get that wrong on the previous? I may have. So at any rate, we are firmly in chapter 12, lest you be worried at all about that. And this is the verbal learning section. And this is just a little part I'm doing in between two larger parts. It just seemed like it kind of fit on its own to me, so I thought I would just do it this way. So here we are, Module 8B, verbal learning, and let's just jump right into this really. To a large extent, as I suggest on the left, the verbal learning craze, and it was sort of a craze for a while. I mean, there was a lot of people that were doing this as psychology, and some still do, by the way. There's a little bit of this verbal learning tradition that continues within cognitive psychology and now cognitive neuroscience. And so this has become sort of a staple, one of the methodological approaches that's very common in psychology today. And that's why I wanted to highlight it a little bit. And so let's start. Let's remember Ebbinghaus. So Ebbinghaus was the guy that created those CVCs, consonant vowel consonants, and tested his own memory, right? He would look at how long it took him to learn a list of those. And then he would see how much he forgot at various periods of time after learning. That was Ebbinghaus's big contribution, was the forgetting function, him showing how it seems as though things we learn decay from memory very quickly. However, he also later showed that you could relearn those things much more quickly than you originally learned them. So did they really disappear? Or, are they just hard to retrieve after a period of time? So at any rate, he was the one that started a lot of those questions, and the people that really ran with the verbal learning tradition were highly influenced by his approach, his methodology. One of the things I hope you'll remember me saying about Ebbinghaus is that he was very precise in his methods, very careful about how he created stimuli, and how he actually defined his experiments. How many trials did he have to do things before he considered them learned, etc. So he was very meticulous about those things. And that meticulousness largely carried over to the verbal learning tradition people, with one exception. Ebbinghaus was big on not using words, because he thought words carried too much with them already. And so he wanted to use CVCs, which were relatively neutral, and didn't have, meaning, or student participants hadn't used them before the experiment, etc. They were new stimuli. When we get into the verbal learning tradition, one of the things you'll see is they use a lot of words. They don't use CVCs. And partly it's because they're interested in a lot of those things that Ebbinghaus thought was the baggage, the potential problem. So Ebbinghaus was trying to use a pure stimuli just to get at how memory worked. But a lot of the people in the verbal learning tradition are actually interested in how the various characteristics of words affect memory. So we will get there. Let's just start over here now. So really the focus of the verbal learning people was about trying to understand the laws governing how associations are formed in memory. And of course, this associationist notion goes back to Aristotle, and we've seen it come over and over throughout this course. The idea that that's what memory does, right, is connect things in various ways. And you'll soon learn about Hebb thinking about this at a really neural level, for example. And so they wanted to understand how these connections are formed and how characteristics of the stimulus itself might affect the formation of these associations. Okay, so the textbook provides this little quote, and it's a good way to kind of think about it, I guess. When they were thinking about the association between items, or that an item forms with other items, they thought it would be a function of a whole bunch of things, and it was these things they were trying to understand. So factors such as the time interval, how long do you get to study a word? If they're presented one at a time, how long is there between each word? Frequency of repetition. Do you repeat words over and over again, or do you only show them once? Other existing connections. Is this word one that is associated with a lot of other words, or is it something that's sort of not very associated with other words? And what do we mean by associated? We can come to some of that. Sensory intensity. Does it matter if you present some bright and some dim? Does that affect their ability to be recalled, to form associations? Affective intensity, the emotionality of the word. Do we form associations differently for high versus low emotion words, etc.? So, really anything you could think about a word, they thought that could affect its ability to form associations. And so let's study that. Let's look at words that have that thing or don't have that thing and compare them in terms of their ability to produce associations. Okay, so they were really into that kind of thing. And by the way, this device down here, it's sometimes kind of interesting to see these experimental devices of old. And this is something called a memory drum. And so an experimenter, if they were giving a list of items for a person to recall, they would type them on this sheet of paper, which they would then roll around this drum. And then within here, this drum would roll at a specific rate. So it could show these items, and you see in the slot here, you see 2 items now. And so the person would be looking at those 2 items, trying to remember them. And after some period of time, this would roll, and another, the next item on the list would appear, and then the next pair in this case, and then the next item. And so it would just kind of go, and it was a way of controlling the presentation of stimuli. Now, of course, computers have taken over this role for a long time now, and you've probably been in experiments where you've been shown words or items on the computer. This was an old-fashioned way to do that, to get that level of precision. Precision was important to the verbal learning people. Okay, so following the book, there's so many studies we could talk about in the verbal learning tradition, but we will just focus on a couple and give you a sense of it. And in fact, one of them, I have to embarrassingly say, was a study I previously attributed to Guthrie in my last lecture. I'd read through this whole textbook, and then when I was preparing the Guthrie part, I remembered this experiment. I thought Guthrie had done it. I thought it was Guthrie's experiment. It wasn't Guthrie's experiment. I had read about it a little later in this section, and I falsely attributed it to Guthrie. We could even think about the psychology going on there, but we won't. But let me give you a little more detail about it here. So it was an experiment actually done by Irving Rock, but it was with respect to Guthrie's claim that repetition. So what Guthrie was saying is, previous people thought for learning that if you repeat something, that the strength, say, between a stimulus and a response would gradually increase until the stimulus response link was strong enough that when the stimulus was there, it would produce the response. But the idea was even before then, there was a link, the notion was, there was a link that gets stronger and stronger with every conditioning trial, with every repetition of the learning experience. And so repetition was thought to increase the strength of associations gradually until they reached a level in which they were actually having an effect. But Guthrie said, but is that true? Maybe that's not true. Maybe instead, every presentation, every learning trial is an opportunity to form an association that you either you form that association, or you don't. And what repetition does is just give you more opportunities to form that association. But if you don't, you don't. There is no gradual buildup of strength. So this was an alternative that Guthrie threw out there. And so now let's look at how Irving Rock went at that alternative and tried to see if that was true or not. Because these verbal learning people are all about the experiment and all about the experimental method, and doing things in as clear a way as possible to try to produce strong conclusions. Okay, and so this is an example. So what Rock did is he first created stimuli kind of like an Ebbinghaus one, but instead of CVCs, he would have 1 or 2 letters followed by a number. And the reason he had 1 or 2 letters is because sometimes the numbers would be just 1, like number 4, let's say, but sometimes they'd be, like you see here, double digits, 12, 48, 13. So he wanted double letters as well. So he might have a pair that's JJ12, another pair that's L48, another pair that's WW13. And so again, these are just pairs he created, and he created 50 of them. Okay, now for a given participant, when they came in, 12 of these were randomly selected. And the participants were first shown all 12 for some period of time, and they're asked to try their best to remember them. And then, so they do their study, and then they flip over their card, and then what we do is we give them the letters. We say, JJ, what was the number that went with JJ? What about L? What was the number that went with L? And these people would try to recall all 12. They typically would not get all 12 on their first go. Okay, and so let's say they got 6. So 6 were correct, 6 incorrect. This is where the interesting thing happens. If it's the control group, when we let them restudy again, we let them restudy the same sheet. That is, it includes the same 12 items they originally got. So it contains those 6 that they were able to recall, but also the 6 that they weren't. And so now they get another chance to learn those 6, right? Interestingly, so that's on their second repetition, let's say. On their second repetition, right, the control group is getting the 6 they remembered and those 6 that they didn't remember, and they get a repetition. They get a chance to learn it again. The experimental group, we add a twist. Any pairs that they recollect, they retain, they stay on the list. So if I got JJ12, I remembered it, then JJ12 is still on the list. But the ones I didn't get are now replaced. Remember, I've got 50, so I can pull some new ones in. So if I only remembered 6, those 6 I remembered are there, but the other 6 are now a new 6, okay? And so they're not being repeated. The ones I'm missing are not being repeated. They're being replaced by new items, right? And what he found is, if you ask, okay, how many times now does a person have to go through and restudy? How many cycles of this, of study and recall, does a participant need in order to get all 12? That's what we want them eventually, to be able to recall all 12. And it turns out that number is about 4.5. So 4 or 5 times they have to go back and study again. But interestingly, it didn't matter at all whether the items they didn't get were replaced or retained. And so the fact that they kept going back to items they missed, and you know, in the control group, they had a lot of repeated study with those same items, but it didn't seem like the repetition improved their ability to learn those items. In fact, they did just as well as when the one they didn't get was replaced and they had to, you know, learn it from fresh every time. And so this really suggested, hey, that repeated exposure isn't really doing anything. What really seems to matter is on each time when you're trying to acquire this information, on each time you get a chance of getting that word. And if you get it, you get it. And if you don't, you don't. And so even if we replace the ones that you didn't get, now next time you got a chance to get that one. Is that all clear? I hope that's all clear. Because, I mean, the cool thing about these, and I as a student got very attracted to these kinds of studies because they seemed very clever. You know, people would have to come up with these sort of manipulations and like, wow, I never thought of replacing her. Now, who would think of that? So there are these clever things, and the results seem to provide relatively clear answers to admittedly relatively simple questions. You know, we end up asking some very simple questions, but we get some clear answers. And so that's one example. Here's another example of what these guys were doing, and you've heard of this one before. But they would give people a list. And so the implication here is let's imagine we had about, you know, 16 or 20 items. Well, maybe more like 20 given the scale. 20 items that a person is supposed to remember. And so we read them these items and we say, try to remember them. And then we say, okay, what do you remember? What we typically find is that people remember the first few items pretty well, and they remember the last few items pretty well. But the ones on the middle of the list, that's where they do the worst. Okay, so we call this good memory for the beginning of the list the primacy effect, and the good memory for the end of the list the recency effect. But we see this function always. Better memory for things that happened at the beginning and the end, and the worst memory for stuff that happened in the middle. And so this is a very clear, consistent effect. So again, something you can get experimentally and see it all the time. The problem with some of this is people say, is this relevant? Like, who cares? What is this telling us? Science always has to battle that question. Psychology always has to battle that question. And people have shown that, this does have some relevance. In fact, if you watch, especially certain movies, especially James Bond movies, for example, your prototypical James Bond movie starts with action. It starts really exciting. And it ends usually really exciting, again with action, with some resolution. Just about every movie ends with some excitement, right? But James Bond movies make a point to start with some excitement. In fact, most concerts that you go to, most musical concerts, the musician will play stuff you know and like early and late, and they will bury the other stuff more in the middle. Why? Because when you leave that movie or when you leave that concert, you're likely to remember how it began and ended. And if it began and ended well, you're likely to think really highly of that thing. Oh, it was great, because those are the parts you remember, right? The primacy and the recency stuff. Anyway, zooming back, the idea again, and just to put this in context, this is the chapter on learning theories. And so this is, an example of people looking at these intervening variables. So for example, they started getting into things like, well, what about word frequency? Some words are more common than others. In fact, Couture and Francis are fairly famous for going through books and literally counting how often certain words occurred per million words. And so they had ratings for everything about how frequent certain words are. There's people that think the age that we acquire a word is important, and those words we acquired early have special mojo versus the ones that come later. There's people who study abstract versus concrete words. An abstract word is like justice. A concrete word is like table. It turns out you remember concrete words better, and you can form associations better with concrete words. Why? Maybe visual imagery, etc. And so anyway, people have just gotten into, let me just talk about this last one, just to show you how kind of crazy some of this can get. One of the questions they ask about words is its neighborhood density. How many neighbors does it have? What do we mean by neighbor? Well, a word like bat, when we describe something as its neighbor, if it's another word that's only one letter off from bat. So said another way, how many words can you create by changing just one of these three letters? So if you change the first one, you can create fat, cat, sat, mat, rat. If you change the middle one, butt, bit, a bot, like a robot, like a bot. We use that term now. If you change the last one, bar, etc. So there's a lot of words that are visually similar to bat. How does that affect its ability to be remembered or associated with other items, etc.? So they looked at all of these sorts of variables, and they also used a bunch of different tasks. Can you recognize things? Can you recall them just from your memory? We've seen the paired associate ones. Sometimes they actually present items mixed with things that are not words at all, and they ask you, is this a word? And so now we're kind of saying, is it in your memory? And does the speed with which somebody can answer that question tell you about the memory store? So all of this to say, remember the behaviorists, don't talk about things going on inside the mind. Don't talk about intervening variables. These are all intervening variables. But what these people thought is, if you did it with experimental precision, you could in fact look at the effect these variables have, and we could learn something about the mind. So the mind starts to come back into psychology, and it does so in these theories of learning kind of experiments. Okay, so that's the verbal learning tradition. I just thought I'd flesh that out a little bit for you. We're going to move onward to talk about Hebb and Sperry and some sort of neuroscience-y stuff, and then end up with Bandura. So that's the next lecture. Cool. I'm going to stop here. Bye-bye.